Second topic, there's four. There must be the force of the attraction forces between the that dyes and fibers. Okay, these forces keep binding of the fibers with the dyes. So one force is the hydrogen bonding. Okay, hydrogen bondings. We know that the hydrogen bonding is formed between the hydrogen atoms and one of the electronegative atoms. Okay, that electronegative atoms may be of the fibers or maybe of the dyes. We know that in case of the fibers, okay, there are the OH groups, number of OH groups, because we see the structures yesterday. In that structure, the molecules of the molecule of the fiber cellulose, there are the glucose molecules are there. So glucose molecules, there are number of OH groups are attached, each carbon having the one OH group. So OH group having the oxygen atoms, and oxygen atom is the electronegative in nature, and that oxygen atoms can be from the hydrogen binding with the hydrogen atoms of the nitrogen groups, and nitrogen groups means the NH2 groups, and these NH2 groups are the present on the dice structures. So these are the hydrogen bondings, and due to the hydrogen bonding there is the attraction between the dyes and the fibers, and that gives the thickness adherence to that particular dyes on the fibers, so it is required. So one of the force is the hydrogen bonding. Second force required for the binding between the fibers and the dyes is the van der Waals forces. So van der Waals forces, these types of forces generally exist between the synthetic fibers and disperse dyes. So there may be the partial overlap of the pi electrons of the aromatic rings of the dyes molecule and the fibers. So we know that in the dyes molecule there are the aromatic structures are there. So one of the polyester having the aromatic ring structure, and dispersed dyes also having the aromatic ring structure. So ring structures are involved in the partial overlapping, that is a pi bond overlapping of the pies. This gives the van der Waals forces between them. Next is the ionic forces. So generally ionic forces are by the ions formations there, and they'll be that is opposite ions attracted to one another's. Okay, and they will be attracted by the opposite charges center in the dyes molecules. Okay, there is a positive charges, negative charges. Okay, depending upon the nature of the carbons, electronegative atoms having the negative charges, electropositive atom, electron deficient atoms having the positive charges. So these ions formation involve in the bonding, so involve in the forces. So this there must be the charges formation. So this is called as ionic forces, and resulting in the salt type chemical liquid linkage between the dye molecule and the fibers. Here the example is given, that is the nitrogen atoms having the positive charges and the acidic dye having the SO3 groups, and SO3 group having the negative charges. So positive charges and negative charges are held together, and this is give the cationic or the anionic group present in the fiber, and these are responsible for the binding between the fibers and the dyes molecules. Okay, these are containing these anionic groups containing SO3 groups and attracted to the each other by the positive, that is NH4 ammonium ions. Ammonium ions having the basic in natures. Okay, so these types with fraction positive charges on the carbon atom and fraction negative charge nitrogen atom, which act as a dye sites. तो इस तरह से वहाँ पे दोनों में बाइंड होता है प्रॉपरली, दोनों के अंदर एडियरेंस होता है, इस तरह से वो जो है डाई है वो फाइबर्स के ऊपर स्टिक हो जाता है, उसको ये भी एक फोर्स रिस्पॉन्सिबल है। उसके बाद नेक्स्ट है कोवैलेंट बॉन्ड्स। तो कोवैलेंट बॉन्ड तो हमको पता है, कोवैलेंट बॉन्ड किससे होता है, शेयरिंग ऑफ इलेक्ट्रॉन से होता है। इफ देयर आर द सुटेबल फंक्शंस फंक्शनल ग्रुप्स इन द फंक्शनल ग्रुप तो है उसके अंदर। ओके, and dye molecules, then the chemical reactions may be takes place. Chemical के chances है वहाँ पर कि तो दोनों भी chemical moieties है. Dyes is also chemical moieties, and fiber is also having the chemical content in that. Okay, so this result in the covalent bond formation between them. Okay, dyes and the fibers. The types of the chemical linkage between them is usually the ether or the ester linkage. Okay, and naturally this will be the strongest force of attraction between the dyes and the fiber, and this is possible with the class of the dye called as reactive dyes. So reaction and have the triazine as the reactive systems, and the hydroxyl group of the cellulosic fiber react with the chlorine atoms forming either linkage, or similarly the reactive dyes called as the ramazoles and the protein fibers form the ester linkage between the dyes and the fibers. These types of dyes will have very good washing fastness due to the strong covalent forces between the dye and the fibers. So here is the dyes that is the reacted with the aqueous alkali solutions and the formation of the covalent bond between the alkali OH solutions, okay, two OH groups and form the cellulose structure bondings. So these types of the bonds are the covalent bond formations. So these are the different types of the forces or different types of the bondings required so that the dyes molecules can be stick to the or adhere to the or give the proper finishing to the dyes applied on that particular fibers. So this second topics subtopic of the unit third we have completed. There are the questions for the practice. You should follow these questions. Okay, make the MCQ by using these questions or by using the theoretical parts. That is third one. That is a classification of the dyes. Okay, how the dyes are classified. So there are the dyeing methods. Okay, one dyeing method is the dyeing method. Generally, the basic operation involved in the dyeing process are the dyeing methods, and the pre-washing of the fibers fabrics is most important part of the dyeing methods. Okay, so fabric which are undergoing the dyeing process must be the firstly pre-washed. Okay, or boiled with the soap or detergents, and this because of this there is a clean of the fabrics because while preparation of the fabrics in the machineries, there may be the chances of the sticky materials or the oils are adhered to the or waxes are adhered or some of the impurities or the naturally present in the fabrics. So that if they are present on the fibers and if we apply the dyes at that time, we not get the proper shade to that particular fibers. So that is why this should be soaked or clean with by using detergents. Next is the preparation of the dye bath. Along with the dye solution, several chemicals are added with the help in different ways. That is the Glauber salt help in the one of the chemical is the Glauber salt help in the absorption of the dyes. Next is the sodium hydrosulfide reduces the wet dye to make it solubles, and the carriers are also there that is act as a swelling agent and increase the rate of the absorption of the dye by the hydrophobic fibers. Next is the content that is the retardants. Okay, act as the retarder which slow down the rate of the dyeing to desired levels. Slow down slow if slow process is last for the more times, and slow dyes in the slow process if you apply the dye, that dye stick to the material fibers for the long times. Okay, so slowness retarders are also there added so that slowly the dyes are adhered to the or dye as mixed with the fibers. Next is the application of the dyes. The fibers or the fabrics is kept immersed in the dye bath at a particular temperatures. Temperature is most important parts here because applying the temperature there is a proper finishings we will get and proper mixing of the dyes is possible. So in the continuous process, either the fibers or fabric is repeatedly moved through the dye solutions or applied under the pressure. Pressure is required. Okay, an alternate direction to, there is a stationary or fabrics. So the process is continued till the concentration of the dyes in the solution become minimum. And this is called as exhaustive of the dyes. Some of the process are involved in these steps are the fixing of the dyes. So dyes, fabrics, fibers is a steam to help the attachment of the dyes to the substrate. And next is the post dye. Okay, that post dye helps the again washed with the okay help for the proper cleaning and proper finishings in which the again wash with the detergent and rinse with the water. This help to remove the and attach the dyes from the dye materials. And next is the finishing process. In this involves the application of the starch or resin on hot processing. This increases the luster and reduces the shrinkage. So these are the process uh, through which the dyeing process is passing. Okay, for the proper mixing, proper applying, proper dissolutions, proper adherence, and removal of the unwanted dyes from the materials. Next is the different methods of the dyeing cotton fabrics. So there are the important methods are there. That is direct dyeing methods is there. In the direct dyeing methods, what they do, the direct dyes are soluble in water. Okay, due to the if it are soluble in water, then it is simple to add that dye to the particular material, that is particular some fabrics. Okay, so this is direct dyes are soluble in water due to the presence of the sulfonic acid group, and the direct dyeing involve the direct application of the aqueous solution to the dye to the cellulosic fiber like cotton, rayon, etc. And a direct dye with the free sulfonic acid group have the less solubility and the lower affinity to cellulosic fiber than their sodium salts. Hence, before preparing the solution, a paste of the direct dye with a little soda ash in the prepared to convert the sulfonic acid group into sodium salt. So this is the process to the applying the direct dyeing process. Dye solution of the particular concentration is prepared and mixed with the common salt or the global salt, and the cotton fibers are immersed in it at a 60 degrees centigrade temperature, and the salt help in the exhaust of the dyes, and hence they are called as a salt dyes. So these dyes are also important for the process. Okay, in the direct dyes have the poor fastness toward the washing. However, they are why it is poor fastness, because the water soluble aqueous in nature. That's why it is a poor fastness. However, they are the exhaustive used to due to the low cost and the simplicity of the dyeing process. So dyeing fabrics is given, and after treatment with the cationic dye fixing agents and the separate bath, and the cations of the dyes fixing agents get complexed with the direct dyes and ion inside the fibers. So there are the examples are also there. That is the orange second is the direct dyes. Okay, Congo red is the direct dye. Direct deep black is the direct dye. These are the water soluble dyes directly applied to the fabrics. Next is the wet dye. So wet dye category is insoluble in waters, and hence they must be applied directly to cellulosic fibers. Hence the dye bath is prepared by adding the paste of the wet dye and the sodium hydrosulfide to caustic soda solution along with the dispersion agents. The wet dye reduced to the colorless leuco compound which is soluble in alkali, resulting in the wet liquor. Okay, this process of the reductions and the solubilization is known as the wetting process. And the cotton fibers fabrics are immersed in wet solution so that the leuco compounds get impregnated into the fibers, and then it is a steam to fix the leuco compound to the fibers. So for example is here the indigo, okay, reduced into the enolic form, and the anthraquinone wet dye are reduced to the phenolic form, which are the soluble in alkalis, These structures are also given how they are applied along with the sodium sulfate solutions. So wet dye is mainly used for the cottons and other cellulosic fibers, and the dyes, particularly anthracene wet dyes, and have very good fastness properties. And the wet dyes are not suitable for the wool, silk, as the fibers are damaged in alkali mediums. So it required the simple, okay, and apply only for the cottons, okay, not apply for the silk and the wools. The wet dye process having the some limitations also. Next category of the dyeing is the modern dyes. Okay, and these methods of the dyeing is used when the dye has low affinity to the fibers. The dye fibers affinity is increased by the adding the intermediate organic or inorganic compounds called as the mordant. And this mordant dye have the group like the OH group, COOH group. There is a functional group attached and capable of forming the stable complex with the metals. So this dye mordant material are there, and then fiber the stickiness form there. Okay, so there are the examples also for that, and in that dye bath is prepared by adding the 2 to 5% of the acetic acid, 10% sodium sulfate to the dye solution, and 50 to 60 degrees centigrade temperature. Then the fiber material is introduced into the dye bath and the solution is brought into the boilings. Then the hydroxide of the aluminum, chromium metals are the added as the mordant. So there is a formation of the complex, and these dyes are called as chrome dyes, or the process is called as chroming. Okay. The modern dye have good light and the washing fastness, and they result in the brilliant color. So examples of the modern dyes are the alizarin, irichrome black tea, okay, indanthrone blue, diamond black. Yeah, these are the examples of the modern dye. Next is the next category is the dispersion types of the dyes. Okay,